So today it's December 6th, Wednesday, and it's going to be yet again an Aerial Robotics Community Working Group meeting. Today is going to be a scientific / presentation meeting where somebody of us is going to present about the topic. So my name is Kimberly McGuire, and I'm doing this together with Ramon Roach from Drone Code Foundation. I'm from BitCraze myself. So the agenda today is just pretty short. First announcements, some technical generic announcements, then a presentation by Ryan about Ardupilot and ROS. Then a topic for our next meeting, and of course, just some final words at the end. So announcements. So apparently ROSCon India will start next week. So that's pretty cool. So if anybody of you is able to go, you should go. I'm unfortunately not able to go, but it looks like they have a lot of great speakers. Also, I think also nice technical information about the ROS Aerial community in general. Somebody, Mayank, had the idea to have possible presentation topics about topics that we would like to see somebody else present who is, like, for instance, like an expert in, for instance, as you can see, like maybe positioning systems for indoor and outdoor, or a presentation about LiDARs and range sensors, or a presentation about cameras and different types and applications. So that we can just like put some presentations just in there so that anybody who feels that they're an expert in this topic can grab that and make a presentation for our meetings. So just want to kind of have your attention on that. Is there anybody else that would like to share anything in this at this time about an event or anything that's happening currently with your aerial robotics adventures? Let's see if anybody adds to the chat. Then I think I've probably already mentioned everything at all. So let's move on to the next one, which is going to be a presentation by Ryan about Ardupilot and ROS. So I will stop sharing my slides, and Ryan, you can go ahead and share your slides. You're muted.
All right. How's this looking?
Yes, I can see the slides.
Sweet. So yeah, I'll be doing a presentation on Ardupilot with Rhys. So quick introduction, I guess, for myself. I started flying drones a bunch of years ago for fun, before they were called drones, mostly fixed wing. And then went to school and learned how to write code and do engineering. And now I did autonomy on ground robots, big ground robots for a while. And then in this year, I moved into aerial robotics for my professional work at AeroVironment. But on the side, I'm part of the Ardupilot development team and work on some really fun stuff in my free time. Rhys, you want to do a little introduction?
Oh, yeah. Thanks, Ryan. So Rhys Mainwaring, been working, don't have a background in robotics. I started kind of working in robotics about 5 years ago, mostly in simulations. So I've done some work with the Gazebo team on supporting some maritime vehicles and some of the rendering work to support different platforms, mainly Mac OS. And segued into working with Ardupilot originally to support one of the developers there who had a sailboat that he wanted to simulate in Gazebo, and then got more involved. And so in the past year, I've been working with Ryan and a couple of GSOC students on improving the support for ROS in Ardupilot, and I've been coming at it from the simulation side and some of the services with the GSOC students. So it's quite interesting, and we've kind of moved it forward to looking at trying to tackle terrain planning, and so it's been good. Ryan's been driving it forward, and I've been happy to help out.
Thanks. So here's the agenda for today. We'll start with architecture, talk about some simulation and testing, talk about the GSOC projects, then go into micro-ROS and ESP32. Then we can talk about rover with nav2, terrain planning, which is some recent work, and then comparison to PX4 approach. I think there's some costs and benefits with both, and then future plans. I do have slide numbers. So if you have questions, feel free to either ask them at the end or interrupt us with a slide number. So I think everyone here knows what Ardupilot is, but I just copied this quote from the website. Trusted, versatile, and open source autopilot system supporting many vehicle types. So yeah, it flies or drives or I don't know what the verb for maritime is, but it works on a lot of different platforms. And I supplied some links here to get started. We'll share the slide links at the end of the presentation, and you can go ahead and click through and go check out all the community join forums and stuff like that. So what I wanted to do was to give a brief background on sort of leading up to the architecture of why things are the way they are and what we're working on for ROS. And so at a high level, when Ardupilot started, you would have a real-time system. I guess this was not exactly when I started, but you know, at some point there was a real-time system with an STM32 with a few sensors, and this was Ardupilot or PX4, and they had some radios that would wirelessly talk to a ground station, either Mission Planner or QGC. And this was sort of how you would fly something in the early days, simple architecture like this. Then ROS came along and complicated things with, hey, I want to run more sensors that we can't run on the RTOS because camera can't run on Ardupilot or any of this low-level hardware. So these companion computers are traditionally Linux-based and different architecture than your development computer, but they do usually fly on drones, so you can wire them up directly to your autopilot, and it's not wireless. So the challenge was initially with this first, with this first architecture, Mavlink was written to talk between the autopilot and GCS, and it was designed for that environment. So it's a lossy link and bandwidth constrained, especially the really early radios had a really low baud rate. So the developers developed this really efficient protocol to do that. And then companion computers also started using it, same Mavlink interface with the same design patterns and constraints. So the problem with Mavlink for companion computers is that it's rate limited to 50 hertz by default on Ardupilot, and the Ardupilot's multi-threaded. The thread priority for Mavlink, because it's intended as telemetry, is pretty low. So that's one problem. And then the other problem is the message stability. So Mavlink can change whenever Mavlink wants to change, and there's a whole process to accept messages into the standard. But that does not necessarily align with ROS releases because Mavlink doesn't require ROS to work. So ROS is sort of a second citizen in this ecosystem of Mavlink. And for companies deploying robots and taking ROS bags, if you change your message definitions, then it invalidates your ability to look at bags unless you can rebuild the messages that were used on that bag. So it complicates things for ROS development teams. And also, if you write applications on top of a changing message set, the applications can sometimes break, which is hard to sustain if you want to keep up to date. So the way this is currently handled largely is with MavROS, where you take Mavlink data, which is serial, you use MavROS, which does a mapping into a ROS message that has the same content as the Mavlink message, and then your ROS app depends on these ROS messages that look like Mavlink. So if you know Mavlink, it's great. If you don't have to worry about, if you're not concerned about taking bags in the field and replaying them without a bunch of infrastructure, and you just want to get something going, it works pretty well. But like I mentioned, the Mavlink interface is pretty low, so there's some limits for what you can do on a companion computer with Mavlink, or at least do it well. So that's sort of the motivating factor for why we chose to not switch, but support DDS. And so what it does is it eliminates the Mav-ROS bridge, which is sort of this translation layer here. And instead, we chose to follow Rep 147, which is a unofficial standard for using ROS in aerial robotics. The key advantage of following Rep 147 to us was that we were going to be stable. We were going to have stable messages within a ROS release. So what that means is in ROS 2 Humble, you can't change your messages with breaking changes. So for application developers that want to have a stable version of the Autopilot or develop on the Autopilot, but then have a stable ROS application interface, it supports that. And so another thing that's big is we can support much higher rates than Mavlink out of the box. 200 hertz is working right now. We've tested up to 400, which is pretty cool, much faster than things we've seen before. And we also didn't break Mavlink, so you can still run a GCS with Mavlink and not break things. So yeah, the key terminology here is you have your Ardupilot instance. There's a micro XRC DDS client running on the Autopilot, and then you have the micro ROS agent running on the other side, and that performs the translation. So that's why we selected DDS and the key motivations for it, for the interface in Ardupilot. So what does that allow you to do when you use standard ROS messages? Well, on the left, we have Mav Proxy, which was the existing Mavlink based visualization. And on the right is Foxglove, which is a common ROS tool for visualizing ROS systems. And we can just hook them together and use some of the built-in Foxglove panels without having to write any application code to translate things. So as a ROS developer, it's pretty handy to be able to debug your system and not have to write a bunch of custom UI for your custom messages and update the UI every time Mavlink changes. So that's sort of the advantage of that and a little demo. The next thing we wanted to talk about was simulation, specifically lockstep simulation. So when you're simulating a ROS-based system with an Autopilot, it's handy to be able to stop at any point in the code and inspect the state of the system. So what Rhys mainly worked on was adding this ability to freeze the current state using GDB. And so the way it works is you have a UDP communication between Ardupilot, Citadel, and Gazebo. And I linked in the exact spots in the source code where this blocking happens. So it's a back and forth communication, and every physics update is checked. So you can block from either side. It's bidirectional. And then on the right is sort of a screenshot of going and debugging with GDB in some Autopilot source code while you have this whole complicated system running. This is a pretty hard problem to do in ROS generally for ROS developers to be able to run a whole stack and also get deep into GDB in the system in an editor environment. So we wanted to get that working early on. So there's instructions on how to use GDB on the wiki if you want to go see how to do that. This is what we're all ROS developers, most of us are ROS developers here. So I wanted to share what a typical ROS developer environment looks like when we have this whole stack up and running. So on the left, we have RViz. So RViz is commonly used for ROS 1 and ROS 2. And then on the left middle, we have Gazebo, which is performing the physics and 3D environment. On the right middle is a terminal for Mav Proxy where you can send commands with Mav Proxy. So that's still the Mavlink interface. You can do things like arm the throttle, take off, change modes, send waypoints and whatnot. And then on the right is the traditional Ardupilot tools, like the Ardupilot map, the Mav Proxy map, as well as the colorized Mav Proxy terminal for the Autopilot. So anyways, we still support all the existing tools, but added a few to the picture, and it is a lot of screens, so it's nice to have either two monitors or some task switching to be able to develop in this environment. Any questions? Yeah, go ahead, Mayank.
Hey, great presentation. I was just thinking, is it a natural evolution to go beyond XRC DDS and consider Xeno Pico as well, considering Xenos coming in as an official RMW for ROS? Is that something we're looking at, or is I saw somewhere, I think in your previous presentation at some other talk, that EPROSEMA has been really nice in terms of their overall help with the integration and stuff, and like, do we rely on such vendor support to be able to do this in a streamlined fashion?
Yeah, I think there's some definite use cases where Xeno is going to outperform micro XRC DDS. The
Exactly.
architecture is different. There are some trade-offs in using it, and it is more code to support. So we're interested in it, but with the size of the development team we have maintaining Ardupilot, we can barely even sustain, or we're able to maintain what we have now, but I don't think we'll have the bandwidth right now to support that unless we trade something else up.
Yeah, I think it might even be a better move to do once Xeno is official as like a proper middleware layer and not like a plugin how it is right now, as far as I understand things. I think that part, the transition from DDS to Xeno as a full-blown middleware is also in progress, as I know.
Yeah, and so the goal when we set out was tight integration with ROS 2, and since Xeno's not quite supported in ROS 2, we're not really getting anything by implementing it right now.
Sure.
And as far as our development time, got more bang for our buck just integrating with DDS directly.
Yeah, makes sense. Thanks.
Yep. So we did get some Google Summer of Code projects this summer. Rhys and I mentored both of these students. We had Pedro and Arsh. Pedro was working on this, mostly the companion computer side with GPS-denied autonomous exploration. And then Arsh, who was a previous GSOC student who wrote the initial DDS implementation, ended up coming back to just do improvements for services, and there's just a lot of work to be done on the DDS interface and Autopilot, and it was really great to have their help to do that. So we had some really successful projects this summer, and thankfully Google was able to fund those students to make some pretty attractive job for these students. So here's a demo for what Pedro did. I'll go ahead and play that. So this is with Gazebo and Google Cartographer. So Cartographer is running SLAM and can perform localization, which feeds the localization to the Autopilot. It's also generating a cost map, and you can plan with RViz to say, go to this point, and then it will, we're using the navigation 2 stack, and so nav2 will go ahead and plan a route, and then the drone will fly it, and it's integrated with Ardupilot. So pretty much all this work ended up getting merged except for the nav2 piece we're still working on, but it's pretty close. It's about to go in. So this is 2D. We didn't get to 3D yet, but it was a good proof of concept that this can be done and use all the latest technology and use the new Gazebo. So a lot of great work from Pedro to get this running. Cool. The next thing is, so it's not just copter. Do you want to talk about this one, Rhys?
Yep, sure. So we've got this is a kind of gazebo simulation with a rover. It's a 6-wheeled skid steer sort of virtual model of a wild thumper, and it's using exactly the same interfaces and nav stack as the Iris, as its 2D problem, with just a very bit of minor configuration change to change the size of the robot footprint and a couple of other parameters determining velocities. You can use everything that was done for the Iris in this, and we just modified or added Python launch scripts to spin up the models. So here it's just 2D planning in a kind of a playpen type world. So this is an upgrade of the classic ClearPath playpen to the latest version of Gazebo, and the rover is fairly straightforward. It's just driven in Ardu rover, so we added external control via DDS for rover as well, and it just works all very nice. So again, we've got kind of MAV proxy up and running is the main ground control system. Ardupilot running in the background, Gazebo on one side, others on the other. So what's quite nice is that once the framework's up in place, switching between different vehicle types, as long as the nav problem is fairly similar, it really does just drop in quite well. So I've provided the various links. I think as Ryan mentioned, we've got some upstream dependencies on the nav2 stack. I think before we get the and Ryan, you might want to speak a little bit more to that, before we get the final pull for the Ardupilot ROS nav configuration in. But otherwise, all the code is there. Most of it is merged and available to use and investigate. So feel free to investigate and ask questions if you've got any follow-up on that as well. Back to you, Ryan.
Yep. So I mean, I guess for the nav2 thing, so nav2 traditionally controls vehicles with velocity control with a twist message, but in Rep 147 it used twist stamped, and we made the decision that it was really important to always have timestamps on the messages from the companion computer to the autopilot, because if they're stale for control data, that's a pretty dangerous situation to be sending bolt commands and have the autopilot do them regardless. So we decided we're going to break support with nav2 and use twist stamped, and then I worked with the maintainers, Steve at nav2, to sort of design a migration pathway so that we could still use twist stamped and Humble. So they agreed upon the design. This has been something being asked for from nav2, and there's other stacks in ROS2 that have already moved to twist stamped for this very reason, like the ROS2 control, I think has already migrated. So anyways, I did all the implementation work in nav2 to support either twist or twist stamped configurable at runtime through ROS parameter. And then in JTurtle, the twist message support is going to be deprecated, assuming the entire ecosystem is moved to twist stamped. But this really involves a lot of pieces to the puzzle, and that's why things have been a little slow to get in, as we want to make sure we do it right. Yep. So I guess, yeah, multi-vehicle simulation. I know everyone wants to do swarming, and it's really exciting. And also it does prove the scalability of your solution. So does it work with multi-vehicles? So with it, you can see we can arrange multiple vehicles in Gazebo. It's possible to do that. You can have multiple camera sources. So simulated, Gazebo supports simulated camera data. And you can run a mission and have the vehicles all fly around independently, and works pretty well. It's still in PR. There's a couple things to work out with the network and namespace that really isn't, there's not any clear design patterns from Rep 147 or other parts of the industry that we can use yet. So I think this is going to be an active topic to really look at how to solve this right and avoid conflicts. Do you want to add anything, Rhys?
Yeah, no, I think that's one of the big things is how to deal with like name spacing in a standard way. So we've got kind of the MAV IDs and things like that, but bringing the whole system up so that it's nice and consistent. And I know there's different approaches, whether you have a different DDS domain for each vehicle or have them all on the same one with namespaces. So there's things to sort out there. The new ROS Python launch scripts are really great for putting these things together, because you can substitute in values for IDs and click things over in the launch scripts, which makes kind of bringing up multiple vehicles a little bit easier than the sort of traditional XML. So ROS2 is quite nice for that. So there's some like work in progress examples, but multiple vehicle support is not something we've spent a great deal of time on. So this is really just a kind of working example, but further work to do here for sure. Back to you, Ryan.
Yeah.
Good question. So are we thinking in terms of like maybe remote ID, because the unique identification problem might be solved at a higher layer, or do we want to abstract that away? So that the MAVROS ID or like some lower layer is what is used for the unique namespacing and may not be dependent on any broadcast mechanism your craft might have outside.
Yeah, I think there's some obvious benefits to just using the Mavlink SysID because that for a domain ID because they're both UN8s and you can just copy them over. But as far as remote ID, yeah, I mean, pretty much everyone needs to be flying from remote ID these days, in the US at least. So it works, but I guess if you're international, remote ID isn't required. So we want to make sure that the software is supported for international people too. So I don't know. We don't really have a good answer yet. We haven't done the design work. We've got some ideas, and there's some tickets linked in at the end. So if you've got some ideas or recommendations, please add them to the design tickets, so we can start to think about approaches. Cool. So next I wanted to talk about continuous integration. So I think it's can be a stereotype with open source stuff that you get stuff working and prototyped and merge it and there's no testing. And we realized early on that really if it's not that many people maintaining this stuff, especially in Ardupilot. It's mostly me and Rhys maintaining the Ardupilot interface. And I'm doing it in my free time, and it's fairly limited. So it can be definitely a problem to try to maintain the complexity of applications that we have. And so we've been wanting to enforce the behavior with CI. And Ardupilot already has extensive CI. So you can go click that link and see that Ardupilot has run 191,000 different workflows since they stood up the CI. The problem with Ardupilot CI is it doesn't involve ROS or ColCon. It's highly tailored to Ardupilot. So with two solutions to solve this, you could either test with 2 levels, or what we determined was test at 2 levels. So one is use the existing Ardupilot CI to compile and test, and then with DDS enabled, because DDS is an optional feature. And we run the same exact test as all the other aircraft and don't do anything new, except DDS is just turned on. And the purpose of that is just to make sure we don't break anything else by enabling DDS. And then the next thing that we recently added was test with ColCon and test against the Rep 147 interface. ColCon also gives you tests for linting, G-test and PyTest, and a host of other tools. So we've got that integrated and tested both levels. And so this is really critical because I don't have time to manually test every single PR. And especially when there's 30 to 40 other active developers in Ardupilot every month changing stuff under our feet in the networking code. Before the CI was in, our ROS interface got broken like 3 or 4 times from networking changes. And the researchers are always wanting to run on latest master for all the features. And so the CI is really nice to be able to support this. And so here's some examples of the recent CI, and we've actually expanded this to go across pretty much all the stack. So a bunch of the code from ETH Zurich didn't have CI, or the CI wasn't working. And so I've been helping and working with Jay on getting that up to speed. And so it's a lot easier for him to accept our PRs when you can see a green check that we didn't break his other stuff. I think we had some questions.
I think it was Samuel that had a hands up.
Yeah, go ahead, Maya.
Is there any thought about capturing performance regressions, considering how the real-time part can be so sensitive, like the loop time being affected or execution time of certain critical functions being affected on the RTOS side, especially with like so much stuff happening with the middleware and like the companion computer coming in. I feel like beyond just breaking stuff, this could also be a concern, especially for something which might just fall out of the sky.
Absolutely. So the current CI testing is really just setting up the infrastructure and the way to check that we're getting messages, because that's what's broken so far is the message, like the initial connection logic will just fail and you won't get anything. So it's more of a smoke test at this point for the ColCon testing, at least for behavior testing. But it would be pretty trivial to modify the test scripts to time over a certain interval. Hey, we're expecting 50 hertz. Let's make sure we get about 50 messages over a second. And then as we start to support higher data rate topics like IMU, it would be important to go test on hardware and make sure we're getting 1,000 hertz or whatever that we want.
because you mentioned like 200, 400 hertz, and I feel like unless you really measure it as automated fashion like this, you really can't guarantee that stuff as you keep pushing new stuff into either side.
Yeah, what we found is we can usually configure up to 200 hertz on the Ardupilot and it'll just work. And then once you start trying to push beyond that, then it becomes very sensitive to how you're using the ePresenter libraries and when you're calling all the update loops. My
point was that you might write that in the spec because you tested it with one version. But if a recent PR didn't break anything per se, but just slowed stuff down, that might be tougher to catch unless we have automation for that too.
Yep. And I just wanted to acknowledge that there's a huge amount of work being put in, and I'm really thankful for all the contributors. But I also wanted to say that it's not necessarily going to be that way all the time. People lose interest. They want to be involved in other projects, and CI is really beneficial for that situation. And that you can make sure as new contributors come along, they don't accidentally break old stuff, and it makes it a lot easier for a maintainer like me to approve contributions if I know that it didn't impact anything else. And I can quickly read the code and quickly hit merge and be able to move on with my day. So Rhys, you're up.
Yep. So one of the things we put in place is that so we went down the route of using the ROS Colcon testing infrastructure, and one of the things before we had our students come on that we wanted to put all this infrastructure in place, and it was really important that because it's a complex system to bring up, it was going to be really important that we could that all the launch code, which forms quite a lot of the logic for assembling complex system like this, is also tested. So we use launch PyTest, which is not actually part of the standard Humble distribution, but it is available for a separate download. To get it to work, there was a little bit of a problem in that. So normally when you compose launch files, the things you get back from those composed launch files are not actually the executable, the object that you want to put on a trigger. So the big problem with like these composite systems is that you need to wait for various parts to be up and running before you can actually start to run the test. So your test case will have wait for this to be available, and then this process to be available, and this process to be available. And if we wanted to check the things that we were launching would be available, you have to set a trigger on that thing being available. If that thing is a generator rather than the actual object, then you can't trigger off it. So we kind of looked at how the launch system was put together, and it didn't quite work. So we found a way of doing it. And so we've moved all of our launch code, rather than being treated as scripts, and actually treat them as first-class code. So they sit inside the module for the particular package that you're delivering as a Python module. You need a standard set of methods on any particular node you want to launch. You kind of generate the action, and this is the actual thing that gets launched because it has the launch context, which has all the finally resolved arguments and things like that. And that's not actually available until you press ROS launch. And it's all kind of, it's potential up until then, but until you actually get the context, the thing isn't fully resolved. So we then have a method to generate launch descriptions with actions. And so in order to get these actions back, as well as the generator, we just tack a dictionary, which has got all the named actions onto the thing you'll get back when you compose them. Generate launch description is what you'd normally have in a launch description file. So that provides the actual launch description that then gets started by ROS launch. And then the arguments are kept separate just because it tidies it up. And what that means is that the actual launch scripts themselves are really one-liners, because you generate your launch description by just referring to the object and the module. So they're really thin. And next slide, please, Ryan. So what that means is that we can then use all the power of PyTest for doing for generating our fixtures, because now we can build fixtures at the same level of composition as all of our launch files. So for every launch file, there's a matching fixture and test case. But then they're all composable, and the launch files are all composable, so you can build up your whole system by composing all the launch files you've got, and you can build up your test structure by building up all the fixtures that you've got that mirror those. And the pattern is the same. You bring in the fixtures. The fixtures have a pair of objects. They have a launch description and a dictionary. And then you can fold in new launch descriptions with their actions as you need them for extending them. You can compose them, and then it's all async. So then you yield again the pair of objects at the end, which is the launch description and the dictionary of actions. So what that means is that your test cases that you're running up are calling through all of your exact same launch code. So you are really confident that if you've got a problem in your launch scripts, this will catch it. And all your code for bringing up the system is in one place, and everything transfers. So it took a bit of fiddling to get all of this in place. And there's a little bit of code in the main Ardupilot CIDL package, which actually provides the type of action that we wind up using, that we may want to pull that out and provide it separately. But this is the thing that allows us to be really certain that if we've got a set of launch scripts and we've got tests that tests the kind of the modules that go with them, we're not going to have a problem. So if you break the launch script, you'll break the tests, and that was really important, because this system, it winds up being really complicated in the end. Its power is through all its component parts, but if you've ever tried to debug somebody else's launch scripts, it can be really difficult. And so this is trying to get on top of that right from the very start. So it's used to bring up everything, whether we're bringing up an actual vehicle or a simulated vehicle. Everything runs through this. And so the CI workflows that Ryan was referring to are calling these through CodeCon test. Or you can run them separately using just PY test. So you can point PY test at the actual test cases and run them separately. So it seems to work very nicely, and it's kind of certainly helped us keep on top of like the code working once we've got it in place. Okay, thanks. Back to Kimberly, yes.
Yeah, just a quick question about like the launch files in general. Because are you guys aware of the newest the event handlers that are using in the event handlers functionality that just released in the launch file API?
This certainly uses the launch. This uses the event handlers that were available in Humble, and I don't know if that behavior has changed recently. So it may. I'd say I'm not familiar with the very latest version of the event handlers, but this makes use of those event handlers. And the key part with the event handlers is that the event handler has a trigger, and the thing that is the trigger has to be an action. So in the whole launch, there's launch actions, which are effectively the thing you get back when you say create a node in the launch Python scripts. They're actions. The launch descriptions themselves are not actions. They are generators that get initiated once they get the actual launch context. And so the problem is that once you start to compose launch scripts using include launch description, the thing you're getting back can't be passed as an argument to an event handler.
Okay.
So this is the solution to that problem.
All right. Yeah, good to know. Yeah, I haven't used these event handlers myself that much, but it's mostly because I've heard that during the ROSCon talk that was one of
they're
the
very
things that were
powerful,
really
and that's what.
Yeah.
So these the things like in process tools, wait for sync start, they are effectively event handlers, and they're waiting on a process to be available, and all that machinery is amazing, but it can't be a launch description, or it can't be a composed launch description. Somewhere in the launch description, if you bury into it, you do have the actions in there, but there's no interface to get them, and they could be 3 or 4 levels down. So you'd have to fish through all of the launch description generators to try and find the embedded actions, and that's just hard and
Yeah.
would be very fragile. So, but because these things, it's Python, so you can pass dictionaries back. The trick is you just tap named actions. So it requires, it's using conventions rather than like sort of code enforcement to do it. So these, you have to kind of structure it well. But if you do this, then you get all the benefits of both. So you get launch composition, test composition, same code for running it through, and you're not having to fish inside these bags of objects to try and find the action that you need.
You're right. Got it. Thanks a lot for explaining.
Okay.
I think Mayanka still had a question.
Yeah.
Hey, Rhys, are there any drawbacks to doing it this way? Because I mean, I get it that PyTest wouldn't work if you didn't do it this way, but like this launch architecture of introducing the generators inside the modules, like, is there something to watch out for, or are there any drawbacks to this?
Not that I've come across. I mean, because like normally all this code sits in the package anyway, but it's under the launch. So quite often all this code would sit inside the actual launch subfolder in Python script. So all we're really doing is just moving it into one place and actually treating the launch code as code,
regular code,
as opposed to like throwaway scripts, because you know, a lot of effort goes into putting the launch scripts in place. And so this allows you to test them, and rather than having to duplicate. So what I noticed in some of the Python, some of the ROS packages, is that the logic for testing launch files in the test scripts was actually duplicating the code that was in the test scripts. It wasn't calling it. And of course, you then need to maintain the things in both places, and of course,
in two places.
Wait for that is to be permanently broken. So this is really just making sure all the code is in one place, put it in a module, and reuse it everywhere.
So maybe people coming from a ROS1 background who think of launch files as the classic XML scripts are still in that hangover of writing the script files kind of like just their own launch entities, and haven't really fully leveraged the power that these event handlers give you, because it seems like something new. So I hadn't seen videos like this before.
Yes. So once they're in Python, you can do quite a lot more in your and that's again the case for like launching multiple vehicles. You can write loops to iterate over things. Your launch argument can be a number of vehicles to launch. You can have a loop in your launch file. So you really want to be able to test that, and that lets you handle all of that. So yeah, sorry, took a little bit longer than expected, but back to you, Ryan.
Yeah, I'm just going to we still have 15 minutes before the end of the meeting, so perhaps we should let you guys finish up the presentation and do all the questions afterwards.
Yeah, I think we're a little bit time limited, so let's hold some questions for a bit, and then feel free to write down slide numbers, and we'll come back if we need to.
Sounds good.
So one of the things, we're using the eProsima Micro XRCE DDS client libraries directly in Ardupilot, which is tying us to that vendor. MicroROS has some advantages that it's abstracted from the vendor and supplies all the ROS niceties that ROS developers are familiar with. So you can do servers and actions and parameters in a ROS-friendly API in the Autopilot code. The challenges with this library is that trying to use the parameters servers will duplicate the memory usage for parameter storage. It has a heavy flash cost compared to the straight DDS libraries. Well, it's actually not super heavy, but it's still a concern. And then the client library, to get it integrated in our build system, we're already having to call WAF from CMake, and then having to call the MicroROS scripts, which are shell scripts instead of an actual build system. It becomes quite the mess to try to integrate it into the build system nicely, like we have with Colcon and WAF right now. So Rhys spent a lot of time working on trying to do this with Arsh during the GSOC project. There's experimental support for it. It's definitely something that we want to try to do and support, because there are like people that use Ardupilot with ROS will probably want this support, especially for parameters and actions, because you might want to drive large parameters from the Autopilot, from the companion computer side. It works on ESP32, which ESP32 removes some of the constraints you have with an STM32 with regards to flash and RAM, because it's pretty powerful. And the micro-ROS libraries are supported on ESP32 already, whereas they're not supported on Chibi-OS. So Rhys has also built it for Maytech H743, and it works over serial, but it's currently it doesn't initialize, and we didn't really chase down exactly what's wrong, but this is on the radar for future support to support. I think these things are really great if we can get them integrated. So this is, as mentioned, in the 3D planning with, I guess, Jay, you're here, so feel free to add whatever you want, but Jay's been working for a number of years on some really great algorithms and actually flying his research code. And he recently released the research publicly, so the code is now open source. And I've been aware of it for a while, and this really is attractive to me because I want to solve fixed wing path planning for return to launch and not crash into mountains. So this work has been years in the making. It's open source. Congratulations to his lab for making something work. I think it's pretty incredible. This is amazing technology, to say the least. There's nothing even close to this in any of the commercial offerings I've ever seen. So it's really cool. And what we've been working on with him, despite Jay coming from the PX4 side, is we want to get this algorithm working on both flight stacks and port it to ROS2. So it was written in ROS1, and Rhys has been leading the effort lately. But yeah, it's now running in ROS2 with PX4, which is pretty exciting. We don't have the support in Ardupilot plane controls to do this algorithm even. We can make some hacks to get it to work. So I think there's some, there's ongoing steps, mainly, as I mentioned, CI is always important. So I've got a PR up for that, integrate it with Ardupilot with MavROS, and then migrate from MavROS to DDS, and to try to abstract the planning code from the visualization code and abstract both of those from the specific autopilot vendor, so it can be used with any autopilot, even beyond PX4 and Ardupilot. Do you want to add anything, Jay?
No, but yeah, thanks for the amazing effort, and it's really cool to see that it works in ROS2. And yeah, thanks for all the effort.
Yep. Cool. So I did want to do a quick comparison. See you, Rhys. I wanted to do a quick comparison between Ardupilot and PX4 because I know we've got a lot of developers here on both sides of that. So Ardupilot right now is using Rep 147 it's largely for message interface. We have tuned QoS for each topic. Currently, we're exposing 11 topics and 2 services. The build workflow and test workflow is through Colcon. The protocol supports either best effort or reliable transmissions, and we're using both depending on the topic. We only support DDS. Both implementations currently are on ROS2 Humble and Gazebo Garden using micro-XRCE libraries and work over serial or UDP. So there's a lot of overlap in the core technologies between these two implementations. But the messages on PX4 are based on the UORB messages. And this is all from when I last checked, and feel free to correct me if this is wrong because I'm not as familiar with it. But there's, I think the QoS is the same for everything. Last I checked, there was 24 topics, so significantly more of an interface exposed. The data transmission is only best effort, not reliable. There's no Colcon integration yet to build ROS applications with PX4 code at the same time. It does support time sync between the companion computer and the autopilot, which is really valuable. As I mentioned, we're trying to do timestamp messages, but we're not necessarily guaranteed sync right now in Ardupilot, which is a bit of a problem. And they support DDS and Xeno, which is really cool to have 2 middlewares on the same stack. So I don't know if there's any major other things to add. One thing that's not clear to me is what the level of automated testing in PX4 for the ROS interface is. If anyone wants to elaborate on that, feel free to. But I know that at least on the Ardupilot side, that we're partially test covered by Colcon, at least have the infrastructure set up to build that out. There's a question for slides. Yeah, I'll post the link in the end for sure. Just a few things left. So future work. This is I presented this slide at the dev conference in March. A lot of this items were solved, and we added a few more. And so what I did is linked in all the GitHub issues. So currently we're working on the outdoor planning to solve smart RTL. So here's a sample mission that we want to try to be able to fly safely. Increased test coverage. I think this is a really great way for anyone interested to get started, is writing tests. We have some researchers who want to do off-board fusion, so we need to support the really high data rate IMU and stuff like that for fusion. As I mentioned, micro-ROS is we're looking into that, welcoming contributions. And then we don't support any waypoint or trajectory stuff yet. Obviously, it's pretty important to actually do missions and not just receive sensor data and do velocity control. So supporting a higher level interface for management of the vehicle. Another thing is obstacles and geofences, obstacles being dynamic and geofences being static. We don't support either, so ROS might try to make a plan that violates the autopilot geofence, which is obviously a bad thing. So another thing that's not supported in Ardupilot at all is testing on hardware, automated. So for me as a maintainer, it's really hard to keep up with pull requests that affect the embedded side that I can't run on my desktop. That workflow of me testing, there's numerous autopilots to try, numerous different protocols. It's a lot of parameters to manage manually. We don't have any infrastructure to test that, so it frequently breaks right now. The other thing is swarming. We want to support multiple vehicles on the same network. We don't have infrastructure yet, but we have got some ideas. And then supporting the custom mode API. There was a lot of really great work in Mavlink to support custom modes. So instead of just saying the drone is unguided and ROS is doing whatever it wants to do, to actually expose that ROS is planning, or ROS is doing terrain navigation, or ROS is doing obstacle avoidance, and have that show up on the ground station. There's support in the stack for this, but not in Ardupilot. So yeah, that's pretty much it. If you want to get involved, we keep track of all the issues here on this board. So feel free to say you want to work on something or propose a new issue and let the maintainers know about it. So yeah, I think we can open it up for questions and then talk about next meeting. Kim?
That sounds good. Let's have a few questions then, and I'll quickly wrap up for today. So anybody who has questions, just raise your hand or ask in the chat, and I can call that out loud. Anyone? I guess maybe most of the questions have already been asked during the presentation itself. I guess I would really want to thank you, Ryan, and also Rhys, to giving this presentation. I'm very happy to see so much effort putting into that, and that activity on the 3D planning thread on Discord, on the open robotics Discord is very encouraging to see Ardupilot speaks for, and even people with maritime background to work together. That's kind of the whole, the ideal situation. So what I would like to ask from you guys, anybody that's working on 3D planning now, perhaps indeed, you've already provided some lists, but maybe just also kind of to think about what can perhaps be improved in terms of organizational wise, so that we can take that for the next meeting, perhaps as input of how we can maybe organize the other potential subcommittees for other topics as well. Since you guys
I think it's going to be especially important to try to communicate some roadmaps and goals, because right now Ardupilot, the ROS interface doesn't have any commercial support, which is quite a bit different from PX4, where I believe Auterion is putting a lot of their own development resources into that interface and fleshing it out and making it usable for the rest of the industry. So we don't have that support yet, and I think if that was an option, companies need timelines and to plan, right? So definitely very important to try to establish some goals and what we want to do, and if that aligns with the company, that they can either financially or time support those goals.
Yeah, that's a very good topic to discuss, how we can at least make that a little bit more easier or something like that. That perhaps maybe there should be a subcommittee that just focuses on that, for instance, finding companies that are actually interested in maintaining these. So let me just go ahead and share the slides
Yep, I'll
from
go stop
the
presenting.
meeting itself. So just to kind of go and wrap everything up. Yeah, so there were quite not a lot of people. Like I think half of you guys weren't here when I did the announcements. ROSCON India next week. Possible presentation topics if anybody wants to present about something that's like a basics aerial robotics topic. It's more of kind of question if anybody else wants to share an event. That now's the time. All right, the time is up. You can also share it in the chat if you like. So we've done quite a lot of topics so far, which is really nice. But of course, like for next year, we're perhaps going to do things differently. So like this is kind of like the upcoming meetings in the GitHub project, and you see like I've only planned one for the end of December, which is pretty much like, you know, the status so far, evaluation of how things have gone, and to kind of like have a very, like, let's say, open discussion about what we've learned so far, what could have been better, what work brainstorm about subcommittees next year. So that's why I asked also kind of to write down your thoughts. And you know, because it's almost Christmas, wear a Christmas hat. Or anything that represents this time of year for you. I was even thinking about, I don't know if anybody would be in for that. If you know Mozilla Hubs, I can maybe create like some kind of 3D virtual environment with Christmas spirit, so we can have a bit of a Christmas party afterwards and discuss that further. I don't know. I'll propose something, but at least let's make it a little bit festive for this final meeting of the year. So yeah, like so it's like the discussion about the end of the year's evaluation, and like, you know, just kind of like a general plan, open discussion on how we're going to handle things for next year. So Wednesday, the 20th of December at 3 p.m. Universal Time, coordinated time. Again, I would like to point people to the GitHub organization of this working group, which is github.com/ROS Aerial. We also have like an aerial robotic landscape there. So if you add an info page if you like, add yourself as a community member. I would also like to share that we're mostly focusing on communication on discourse on the open robotics discourse. However, we also have a separate channel on the Discord channel server of the Open Robotics Foundation, which is, especially in 3D planning, very active, which is a lot of fun to see. All right. And of course, if you want to do a presentation in the new year, please give me a shout out or Ramon so we can plan you in. So that is all for today. Again, a lot of thanks to Ryan and Rhys for a very interesting presentation. And yeah, I'll see you guys at the next meeting. I will share all the videos and slides on Discourse on the same thread
Yeah,
where I
I'm happy
announced
to
this
stick
meeting.
around for a few minutes for other questions. I know there's a lot of content there.